January 15th, 1919. Commercial Street in the North End of Boston. A little after noon, on a mild day that has followed a hard freeze. In the shadow of a large steel tank on the waterfront, dock workers stop to eat lunch, and a few people fill cans with the molasses leaking from its base. That tank was the reason for everything that happened next. It stood on the waterfront, between the harbor and the elevated railway. It was about 50 feet tall and about 90 feet across, and it held roughly 2 1/3 million gallons of molasses. That was not molasses for the table. It was raw material, shipped up from Cuba and the Caribbean, waiting to be turned into industrial alcohol. During the war, that alcohol had gone into munitions. The tank belonged to United States Industrial Alcohol, which distilled it through a subsidiary, and it sat in the middle of a crowded working neighborhood of Italian immigrants, freight yards, and a fire station, because that was where the waterfront and the rail lines met. The North End in those years was one of the most crowded places in the country. It was the immigrant door of Boston, tenements packed close, and by 1919 it was largely Italian, families who had come over in the decades before and taken the hard jobs on the docks and in the freight yards. The tank went up among them. There was nothing that would have kept a vessel holding more than 2 million gallons of industrial feedstock out of a block where people slept. Land on the waterfront went to whoever could pay for it, and a company that needed molasses off the ships and into storage could pay. The molasses mattered because of what it became. Distilled, it made alcohol, and alcohol in those years had two markets pulling at it. One was industry and the military, where it went into munitions and solvents through the war. The other was drink, and the drink market was about to close. The push to ban alcohol nationwide had been building for years, and the amendment that would do it was ratified the day after the tank failed, on the 16th of January, 1919. A company sitting on molasses had reason to move fast, to run it through the still while the running was worth the most. Speed was money in that business. Speed is a thread that runs through the whole story, from the tank that was rushed up, to the shipments that kept it filled, to the afternoon the walls could not hold. The neighborhood knew the tank leaked. Children were sent to scrape molasses off the seams and carry it home. The drips ran brown down the steel and pooled at the base. This was not a secret, and it was not treated as an emergency. It was treated as a smell, a nuisance, and, for the poor, a small free thing. That detail matters because the leaking was the warning, and everyone nearby had learned to read it as ordinary. To understand how the tank got there and why it leaked from the day it was filled, you have to go back 4 years to the man who ordered it built. His name was Arthur Gell. He was a treasurer at the company, an accountant by training and by temperament. He was not an engineer. He had no training in structures, in steel, or in the loads a tank full of liquid puts on its own walls. But the company wanted a tank on the Boston waterfront, and it wanted it fast, because molasses was arriving by ship, and there was money in getting it into storage before the market moved. So the job of building it fell to the man who watched the budget. The tank went up in 1915. It was assembled from curved steel plates, riveted together in overlapping rings, thicker at the bottom where the pressure was greatest, and thinner toward the top. The plans specified the steel. By the account that came out later, the steel that arrived was thinner than the plans called for, and nobody with the training to catch that was standing on the site to catch it. The man in charge was reading invoices. Riveted steel tanks were common then. Welding, which would later replace rivets for joining large steel structures, was not yet standard, so a tank like this was stitched together with thousands of rivets through overlapping plates, and every rivet hole was a small absence of metal in a wall that needed all the metal it had. Done right, with steel of the correct thickness and toughness, and with the load properly figured, such tanks stood for decades. Done in a hurry, by a company in a hurry, checked by a man who could not read the drawings, the same design became a row of weak points waiting along every seam. When a tank like this is finished, there is a standard test before you trust it. You fill it with water. Water is heavy, close to the weight of molasses, and it is cheap. And if the tank is going to fail, you want it to fail full of water and not full of product. Filling it lets you walk the seams and look for leaks while the thing is under real load, with nothing at stake but a wet floor. The tank was never given that test. By the account that came out later, Gel put only a few inches of water in the bottom, nowhere near a full load, and then declared it ready. The first real weight the tank ever carried was its first shipment of molasses. It leaked at once. Molasses came through the seams and ran down the outside, and people in the neighborhood noticed, and some of them started collecting it. The company's response to the leaking is the part that is hardest to explain away. It did not drain the tank and inspect the steel. It had the tank painted. The steel was dark already, but the molasses running down it was darker, and a coat of brown paint over the whole tank made the streaks harder to see from the street. The drips were now the same color as the wall. The leak had not been fixed, it had been hidden. The tank did not go quiet after that. It was filled, drawn down, and filled again, and each cycle worked the steel. People who spent their days near it said it groaned, and that the seams kept weeping. One employee grew worried enough about the leaks and the sounds that he reported them, and by his own later account, took to checking the tank himself. The complaints did not bring an inspection. They brought the paint. For 3 years the tank stood on the waterfront, leaking under its brown coat, and the neighborhood folded it into the ordinary hazards of a working street. So by early 1919, you have a tank built cheap, filled without a proper test, leaking from the start, painted to conceal the leak, standing full above a street where hundreds of people lived and worked. And you have one more thing, delivered in the days before, that helped push it over. Boston had been cold. In the middle of January, the temperature climbed, and on the 15th it reached about 40 degrees, warm for the season after a hard freeze. 3 days earlier, on the 12th, a fresh shipment of molasses had been pumped into the tank, and that shipment had come in warm from the ship. Warm molasses in a nearly full tank, in a neighborhood, on a mild day. Molasses ferments. Fermentation makes gas. Gas builds pressure. Whether that was the trigger, or only part of it, became a question for lawyers and engineers for years. What is certain is that the tank was under more strain that day than the thin, untested steel had ever been proven to hold. A little after 12:30, the tank came apart. People nearby said they heard it first, a rumble or a sound like a machine gun, which is how several of them later described the rivets. The rivets held the steel rings together, thousands of them, and when the wall began to go, the rivets fired out of their holes, one after another, fast. Metal shot into the air. Then the wall itself split. The steel peeled open, and the whole load came out at once. Witnesses disagreed on the size of the wave. Some said 15 feet high. Some said 40. In the confusion of a thing no one had seen before, the numbers ran wide, and the honest answer is that nobody measured it. What is agreed is that it was tall, and that it was fast. Estimates put it near 35 miles an hour as it left the tank. That is faster than a person can run, and molasses in that volume does not behave like syrup on a plate. In bulk, moving at speed, it hit like a wall of wet cement. It went straight across Commercial Street. It picked up wagons, horses, and the men who had been working the yard. It slammed into the buildings on the far side. Nearby stood the firehouse of Engine 31. The wave hit the building and shoved it off its foundation, and firemen inside were caught in it. The elevated railway that ran along the street had a support struck hard enough to bend, and the structure sagged toward the ground. A train had passed only shortly before. Had the timing been a little different, it would have come down onto the wreckage below. The damage did not stop at the street. The wave pushed loaded freight cars in the yard, tore at the pier, and drove wreckage and molasses toward the water, so that the edge of the harbor filled with a mix of syrup, timber, and debris. Buildings on the far side of the street had their lower floors stove in. Horses that had been standing in the yard were knocked down and could not be freed, and most of them did not survive. In the space of a few seconds, a working waterfront became a field of wreckage held together by molasses. The people caught in the open had almost no chance. Molasses is dense. A person knocked down in it could not get up. It filled mouths and noses. It pinned arms. Some were killed by the debris the wave carried, the timbers and wagon wheels and pieces of the tank itself. Some died in the molasses where they lay. The count, when it was finally settled, was 21 dead. About 150 were injured. The dead were not statistics to the North End. They were teamsters and laborers and city workers, and among them were 2 children, 10 years old. These were the people who had lived beside the tank, who had collected its leaks, who had been told, in effect, that it was safe enough to stand under. The rescue is where the strangeness of this particular disaster set in, because the thing that had killed people now made saving them almost impossible. Molasses at 40 degrees and above flows. As the afternoon cooled and the days passed, it did the opposite. It thickened, it went stiff and heavy, and gripped everything it had covered. Rescuers waded into it and could barely move. Ropes and stretchers fouled in it. A person buried in stiffening molasses had to be cut and dug free, and some could not be reached in time to matter. The search for bodies went on for days, because the molasses had to be pulled apart to find them, and some of the dead were not recovered until well after the flood, so coated and so buried that they could not be identified at first sight. Help came from wherever was near. A training ship was docked not far off, and sailors from it came ashore and into the molasses to pull people out. The Red Cross sent nurses. Soldiers, police, and firemen worked the wreckage alongside neighbors who were digging for their own. They worked in a field of syrup that dragged at every step and grew heavier by the hour, and they kept at it long after there was any hope of finding anyone alive. The dead were brought out over days. A nearby building was used to lay them, and families came through to look for the missing among bodies still dark with molasses. Some were found quickly. Others were down in the wreckage or out toward the water, and the last of them was not recovered until days had passed. For a neighborhood where everyone worked within a few streets of everyone else, the losses were not spread thin. They landed on the same blocks, the same trades, the same families. The cleanup ran for weeks. Crews used salt water pumped from the harbor and sprayed it over the streets, because plain fresh water only spread the molasses thin without lifting it, while salt water cut it better. Sand was hauled in to soak up what was left. The molasses got onto everything and everyone. It rode into the streetcars and the trains on the shoes and clothes of workers. It coated the streets of the North End, and it turned door handles and railings sticky across a wide stretch of the city. The harbor itself ran brown. For weeks, the water off that waterfront was the color of the thing that had spilled into it. While the neighborhood was still digging out its dead, the company was already explaining what had happened, and its explanation was not thin steel. The company said the tank had been blown up. It said a bomb had been placed against it, or inside it, by someone who wanted to destroy it. In January of 1919, that was not a wild thing to say out loud, because the country was in the middle of a wave of real bombings. A group of Italian anarchists, followers of a man named Luigi Galliani, were mailing and planting explosives aimed at officials and businesses. Later that same year, they would set off blasts in several cities on a single night. The North End was heavily Italian. The company's tank made alcohol that had gone into weapons. Pointing at anarchists fit the fear of the moment, and it pointed suspicion at the very neighborhood the tank had been standing on top of. It was an accusation with a clear motive behind it. If a bomb destroyed the tank, the company was a victim. If the steel failed, the company was to blame. 21 people were dead, and about 150 were hurt, and the difference between those two stories was the difference between paying nothing and paying a fortune. There was anger in it too. The people of the North End were immigrants and laborers, and the company that had put the tank among them was now telling the newspapers that their own neighbors had bombed it. The idea that the tank had simply been built badly, by men who did not have to live beneath it, was not the story the company wanted told. For the families, the bomb theory was not only wrong, it was an insult set on top of a funeral. So it went to court. The victims and their families, along with others who had lost property, brought their claims together against the company, and the cases were combined into one enormous proceeding. It was among the largest such actions Massachusetts had seen. Rather than run it before a jury, the court appointed an auditor, a man named Hugh Ogden, to hear the evidence and sort out the truth. He sat for years. The hearings ran from 1920 into 1925. Thousands of witnesses were called. Engineers testified for each side, one set swearing the tank had been sound and destroyed by a bomb, the other set swearing it had been built to fail. The proceeding became a marathon. By the end, it had run through years of hearings, thousands of witnesses, and a record that filled tens of thousands of pages. Ogden's job was to wade through all of it, the engineers and the metallurgists and the neighbors, weigh the physical evidence against the bomb story, and decide what had actually torn the tank open. He was, in effect, the whole jury, and he took the time that a case that size demanded. The company's own experts could not hold the bomb theory together. A bomb blows outward from a point, and it leaves a signature, and the pattern of a tank that has been blown up does not look like the pattern of a tank that has burst from the pressure inside it. The physical evidence pointed to the steel. The plates were too thin for the load. The steel was of a kind that could crack rather than stretch when it was overstressed, especially in cold, the sort of steel that fails suddenly instead of bending and giving warning, and the holes punched for the rivets had left the plates weakest exactly where the stress was highest, along the seams, which is where witnesses had heard the rivets go. The tank had never been tested with water. It had leaked from the first fill. All of it was in the record, and the man who had signed off on it had been an accountant. In 1925, Ogden ruled. He found the company responsible. He rejected the bomb. The tank had failed because it was not strong enough and had never been proven strong enough, and the company that built it that way was liable for what it did to the people below. The company paid. The settlements came to a large sum for the time, reported near $1 million, divided among the families of the dead and the injured and the owners of what the wave had wrecked. The ruling did more than move money. It changed the rules for how a thing like that tank could be built at all. The disaster, and the long hearing that followed, became one of the cases that pushed states to require that structures be designed and signed off by engineers who were licensed and accountable. and that the plans be filed and reviewed by someone with the authority to reject them. The exact thing that had been missing on Commercial Street in 1915, a trained person with the power to say no before the tank was filled, was written into law in the years after. Much of modern building code was argued into existence by disasters, each rule a response to a specific way that something had already failed. The molasses tank was one of those failures, and the requirement that a real engineer stand behind a stamped plan is part of what it left behind. The failure kept engineers busy long after the settlements were paid. They studied the steel and the seams and the cold, and returned to the disaster again and again as a lesson. Part of what made the flood so deadly, and the rescue so slow, was the way molasses behaves as its temperature drops. Warm, it pours. Cold, it turns stubborn and thick, and resists being moved at all, which is why a wave that crossed a street in seconds set around the people it had caught, and would not give them back. The molasses flood became a case taught to engineering students, an example of how a structure fails, not from one dramatic cause, but from several ordinary shortcuts stacked on top of one another. The company that owned the tank did not build another one there. The tank was gone, torn open on the day it failed, and the site went to other uses. Over the decades, the waterfront changed around it. The elevated railway that the wave had bent was repaired, ran for years more, and was eventually taken down as the city rebuilt. Today, the ground where the tank stood is a public space, a park, and a recreation field by the harbor, with a small plaque that most people passing through do not stop to read. There is nothing left of the tank to see. What the disaster left in the record is precise, and it is worth holding on to against the way the story is usually told. This is often repeated as a light event, a flood of syrup, a joke about a sticky street. It was not a joke to the North End. 21 people died in it, most of them poor, some of them children, killed by a tank their neighbors had known was leaking, built and filled by a company that then tried to blame the dead neighborhood for its own failure. The humor came later, from distance, from people who did not have to dig a relative out of stiffening molasses in the middle of a Boston January. There is one more thing the disaster left, and it is the part that cannot be filed or measured. For years after, people in the North End said that on hot summer days, the neighborhood still smelled of molasses. They said it rose out of the ground, out of the seams of the old buildings, out of the cracks in the pavement, when the sun warmed the same streets the wave had covered. Whether that was real or remembered, the accounts of it are consistent, and they went on for a long time. The molasses had gotten into everything in January of 1919, and the people who lived there believed the ground never fully let it go. The company merged, changed hands, and its name faded into other names, the way most companies from that era did. Arthur Gell, the treasurer who ordered the tank and skipped the test, gave his testimony and stepped out of the record. The engineers argued their theories and were paid and went home. The park by the harbor fills with people on summer afternoons who have no idea what stood there. 21 dead, under a painted tank that leaked from the first day.